Hello there and welcome to the series of videos going through the content of A-Level Maths. Here we're looking at a sum to infinity, specifically in a geometric series, so we can answer questions from exercise 3e. So what we're going to do here is we're going to set un equal to 1 over 10 to the power of n. So for the first four terms, this is going to be 1 over 10, 1 over 100, 1 over 1000, 1 over 10,000. As decimals, they're going to get really small. And you can effectively see here that if we were to add all of these decimals together, it's never going to get very big. It's just going to remain at about 0.111111, and the more terms you add together, the more ones in decimal places you're going to have. So it effectively converges to 0.1 recurring, or effectively the sum for infinity is exactly equal to 1 over 9. So in this case here, we've seen a possible case where if we add an infinite many numbers up, it actually equals some fraction, in this case 1 over 9. And this generally happens for when we've got a common ratio between each of the terms that's less than, or rather in between, -1 and 1, not including -1 and 1, a bit like this thing here. So when our ratio is a decimal number, or a number that's in between -1 and 1, our series will get continuously smaller, such that when you then add up this continually smaller sequence, it turns towards a whole number. And you can add this up to infinity and it will still tend towards that whole number. So let's have a look at another series here. So think about what happens to r to the power of n is if your r value is a decimal number. So as r increases, or as the power on this decimal number increases, what's going to happen? If we have a value like this, which we keep increasing the power of, the value becomes increasingly smaller. If you do a half to the power of 2, you get a quarter, and so on and so on and so on, such that that value will start to get infinitesimally small, such that it virtually tends towards 0. So if you do it with 0.5, like I was just then, as we increase the power on the 0.5s, effectively the r to the power of n term effectively just tends towards 0, and it's after you've reached infinity, it's nothing, it's 0. So as n tends towards infinity for when r is a decimal value, our summation formula turns into this. So it's effectively s infinity for a over 1 minus r. Okay. So let's have a look at this sequence summation here. So find the first sum of the 10 terms in this sequence. So in this case here, we're going to use a is equal to 1 over 6. So a is equal to 16, r is equal to 0.5, and substitute it into the formula to work out the sum of the first 10 terms. So in this case here, we're going to get 31.96875. Now when we work out the sum to infinity, so if we were to continue this sequence on and on and on and add them up, then this is the formula that we'll use instead. The only time that we can use this formula is when the ratio is in between -1 to 1. 0.5 is in between -1 and 1, so we are okay to use this formula. So let's go ahead and do it then. 16 over 1 minus 0.5, that will give us 32. So if we were to add these numbers up for infinity, we would get exactly 32. Okay, let's have a look at another question here. Then the fourth term of a geometric series is 1.08. The seventh is 0.23328. Show that the series is convergent. For it to be convergent, we need r to be in between -1 to 1. And for part B, calculate the sum of the infinite series. So what we need to do first is work out a and r. We know that the fourth term, or in other words, AR to the power of 3 is equal to 1.08, and we know the sixth term, or in other words AR to the power of 6, is equal to 0.23328. Now if you remember a couple of videos ago, the way that we solve this two simultaneous equations is to divide equation on the right hand side by the equation on the left hand side. So effectively equation 2 divided by equation 1. And doing this, on the right hand side we're going to get r cubed, and the decimal that we're going to get on the left hand side is 0.216. And now doing a bit of cube rooting, we get 0.6 as our r value. So to show that this series converges, we need the r value to be in between -1 and 1, which it is. 0.6 is in between -1 and 1. So therefore the series is convergent. What it means to be convergent is that if we were to add up for an infinite amount of numbers in a geometric sequence, that it would tend towards some value. So for part B then, calculate the sum of the infinite series. We need to work out A first. So subbing in r into one of the equations, and we get A as 5. So we know A is 5, we know R is 0.6. We don't need N because N is infinity, but we're going to use a different formula, which is this one here. Substitute in the values and we get an answer of 12.5. Okay. Final question here then, for a geometric series, first term A, common ratio R, S4, so the sum of the first 4 terms is 15, and the sum of the infinite terms is 16. And the question is probably work out the value of R, and given that all terms are positive, find the value of A. So in this case here, we're going to add up the first 4 terms using our formula and set this equal to 15. In this case, we're going to form a simultaneous equation. And we're going to do the same thing for the S infinity equals 16, but we know that the series is going to be convergent, so therefore we can use the sum to infinity formula instead. So in this case here, 16 is equal to A divided by 1 minus R. Now in this case here, what we can effectively do is spot, so that if we just take and isolate this part of the left-hand side simultaneous equation, this is equal to 16. So just replace this part of the formula here, or this part of the equation here, with 16. And now just rearrange to work out what R needs to be. In this case, R is either going to equal positive half or negative half. But it says here, given that all the terms in the series are positive, so in this case here the common ratio is going to be a half. So substituting in the positive value of A, so the positive value of R, we get A is equal to 8. So we found out the value of R and the value of A. Alright then, your turn to have a go at a couple of questions here then. So pause the video and try these two out. We'll go through the answers afterwards. Okay then, so let's have a go at part A then. In this case here, A is equal to 10, R is equal to minus a half. So in this case here, the sum of the infinite summation here is going to be 10 over 1 minus a half. So in this case here, it's going to be 10 divided by 3 over 2, which is going to be 20 divided by 3. Okay, so that's the answer to part A. The answer to part B, A is going to be 3, R is going to be a third. So in this case here, the sum to infinity on this convergent sequence is 3 over 1 minus a third. That's going to be 3 over 2 thirds. So this is going to be 9 over 2. And for part C here, so if you don't know the ratio, the common ratio, you can just do the second term divided by the first term, or any of the terms divided by the term before it. So 8.1 divided by 9 is 0.9. So that's the common ratio. The a value, the starting term, is 9. So in this case here, the s infinity, or the sum up to infinity, is going to be 9 over 1 minus 0.9. That's going to be 9 over 0.1, so that's going to be 90. Okay, so these are our 3 answers for question 1. Hopefully we did okay there. It's just applying the s infinity equals a over 1 minus r formula. Okay, so for a geometric series, a plus ar squared plus all the way up to infinity, s3. Now remember, s3 is equal to ar squared, which is equal to 9. And s infinity, which is a over 1 minus r. Sorry, no, that bit there was wrong. We need to use the proper formula on the sum here, so it's going to be s3 is equal to a times 1 minus r cubed over 1 minus r is equal to 9. And in this case here, a over 1 minus r is equal to 8. It's interesting here to see that s3 is bigger than s infinity. It looks like here we could possibly have a situation where we've got a negative and a negative common ratio here, or a negative starting term. So in this case here, what we're going to do is we're going to replace the a over 1 minus r term in the s3 term here with 8. So it's going to be 8 times 1 minus r cubed equals 9. Divide through by 8 and then swap it round, so we're going to get 1 minus r cubed equals 9 over 8. Subtract this onto the other side and add r cubed onto the other side, and we're going to get minus 1 over 8 equals r cubed. So r here is going to equal minus a half, which was my suspicion that r would be a negative here. A here is going to be, let's calculate it, a over 1 minus a half equals 8, so that's going to be 3 over 2, so it's going to be 8 times 3 over 2, which is 12. So in this case here, a is 12, and r is minus a half. Good, so we've answered the questions here, questions 1 and 7 from exercise 3E. Have a go at plenty more of the questions from exercise 3E. Make sure you persevere through the difficult ones here. Do answer the exam type questions. They've got a little E next to them. You know which questions they are, hopefully by now. Make sure you practice those before moving on to the next stage. Thanks very much for watching.